If you're looking for an open source observability solution, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is part of the Kubernetes series where we already have lots of episodes. How to collect metrics, what is Kata, how to collect logs from your Kubernetes cluster, what is vCluster, and more. Today's episode, I will present an open source observability solutions, and I'm referring to Apache SkyWalking. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. We'll start with an introduction reminding how we manage our observability data. We will explain what is Apache SkyWalking, look at the architecture, the various agents provided by SkyWalking, how to observe your Kubernetes clusters with SkyWalking, and how to get data from a service mesh and specifically Istio. As you may know, there are many ways of managing your observability data. In reality, we could clearly divide our observability journey in 2 to 3 parts. Part 1, we produce data or we collect the data. This is where all the frameworks like OpenTelemetry, Fluentbit comes into the picture. We could utilize OpenTelemetry to instrument our application, the collector or Fluentbit to collect metrics, logs, traces, and send it to one or several observability backend. Part 2 is the actual storage. It's the observability solution. Part 3, once we have the data, we are actually going to use the data to build dashboards, alerts, remediations, and more. This part is highly dependent on the backend that we have decided to choose. In terms of backend, there are obviously different approach. First, there is select different backend storage for each individual signal. So one backend for metrics, one for logs, one for traces, and probably one for profiling. I would say that it would be the most inefficient way because it would be more challenging for us to utilize the data to troubleshoot or generate auto-remediation. I mean, you won't be able to cross-correlate your data between metrics, traces, and logs. So you would have to be very creative to bring everything together. Keep in mind that the way you store your observability data will limit your ability to extend to a number of use cases that you can achieve with your observability data. Observability is not only limited to operation tasks, helping us to measure the health, the performance of our systems, but you can also imagine to extend it to business, to marketing use cases, and probably more. But it requires to be able to utilize all the signals to be able to produce meaningful assets of your data. The second option is to utilize a vendor observability solution that will provide many features, making our observability journey much more easier. Your observability vendor would of course support OpenTelemetry, but also provide instrumentation agents to make our life easier. But one thing that we usually forgot is the storage. They are providing us a reliable storage that we could use and then query our data. I've seen lots of projects trying to build their own observability storage. Well, it is technically possible, but making it reliable and handle a high volume of data is often a different story. Most of the vendor has more than thousands of developers to build features, making sure that a solution can handle 1 terabyte per second of data without any issue while we are querying the data and utilizing all of their screens. So that is often the reason why when you start to have lots lots of observability data, then a vendor solution will make your life easier. Last option is selecting an open source solution to store all your observability signals. There are a few solutions out there supporting the storage of all the signals. So Signals, that is clearly a solution that dedicates an episode, OpenSearch, Apache SkyWalking, and probably more. In fact, if you are aware of a solution, an open source solution that supports all the signals, drop a comment below. Apache SkyWalking is a project that initially started in 2016, which means way before OpenTelemetry. And you will see that this explains few limitations of Apache SkyWalking. Apache SkyWalking provides the platform helping us to understand our environments. To do so, it will rely on metric, traces, logs, and profiling. And one important concept with Apache SkyWalking is that it structured the data in 4 core concepts. You have the service instance, the endpoints, and the processes. The service is, in SkyWalking, a workload in Kubernetes that could rely on multiple pods or containers. Service will show the behavior of our application, the response times, the error rates, and so on. Then you have the service instance, where here it's a particular instance of a service. So in the case of Kubernetes, it could be represented as a pod, for example. Endpoints is a path of an incoming request, and processes is the system process of our services. Last, there is a layer that represents the infrastructure layer of our application. So it could be Kubernetes, it could be operating systems like Linux, Windows, and more. One important thing with Apache SkyWalking is that the traces sent by a third-party library like OpenTelemetry will be considered almost like logs. Okay, interesting. They would be saved, but it won't run any metric analysis from the traces that has been ingested. It means that it won't have any data relationship between services, instance, endpoint, processes. This concept of service and service instance is very important because SkyWalking is providing a query language for those signals. So we either have a query language for traces called Observability Analysis Language. There is a query language for metrics called Meter Analysis Language, and last one for logs called the Log Analysis Language. If you look at the technologies supported by Apache SkyWalking, then wow, we can get very, very excited. It is able to observe services, Kubernetes, traditional infrastructure. On the application level, it has several options using the SkyWalking agents that are supporting language like Java, Node, Python, Go, PHP, and the community provides a support for C++ and C# instrumentation. It also mentioned the support of profiling, and it is technically able to support OpenTelemetry. The documentation of Apache SkyWalking is split in several layers. You have the probes, collecting metrics, traces, logs, events. The probe supports different technology like Zipkin, Prometheus, Zabbix, and then you have the backend server that will process, aggregates, and analyze the data. Then you have the storage, where it could be either Elasticsearch, H2, MySQL, TidyDB, PostgreSQL, BanyanDB, or even your own custom implementation. And then last, you have a UI helping us to interact with the data. There are several probes available to collect data. So we have language-based agents. We have the service mesh. So SkyWalking has the ability to ingest data from a service mesh. In fact, not a service mesh in general, only Istio. For that, it will require several requirements to be able to see the control plane, the services, and the data plane. We have third-party instrumentation libraries. So SkyWalking has the options to ingest Zipkin or OpenTelemetry traces. And for us in this channel, this is exactly almost like a requirement. We're looking for that. Apache will support OpenTelemetry, but it would technically convert OpenTelemetry into Zipkin. Okay, sounds again interesting. And one disappointing aspect is that OpenTelemetry traces will be considered to be logs. It is not able to create a service instance based on our OpenTelemetry data. So all the beauty and the value of Apache SkyWalking will be sound a bit limited when it comes to OpenTelemetry. Then you can observe your Kubernetes cluster and you will see that there are a few requirements. We'll talk about it later on. Last, Apache SkyWalking has an eBPF agent to collect infrastructure network metrics and profiling on Linux environments. One interesting aspect is the notion of satellites. So satellite is like a sort of collector, helping us to receive data, process, forward it to Apache SkyWalking. And at the end, when deploying SkyWalking in Kubernetes, you will have the core components of SkyWalking, so which means the server called OAP, that will provide the logic to receive and aggregate the data. Then you have the storage. The storage really depends on the type of storage that you have selected. And the UI, of course. But you will need more components to observe your system. It depends on what you're planning to achieve. One important aspect related to SkyWalking is that if you want to take all the benefits of SkyWalking, then you would have to use their agents to produce data. I was surprised to see this approach, especially since the entire observability market is now relying mainly on OpenTelemetry. Once you have used their agents, you will get lots of value assets, the topology view, showing you the service flow, the communication, the network communication between the different components, the various endpoints of our services, the traces produced by their agents, and more. So if you're planning to send OpenTelemetry data to Apache SkyWalking, then you will be very disappointed. The logs, metrics are like a raw data, so you will have to find your data to create your own dashboards and your own visualization. So at the end, if you do so, why don't we use Grafana instead? So if you are ingesting custom metrics or custom traces, you will have to learn their custom query language for traces, metrics, and logs to be able to build your own visualizations. SkyWalking provides several agents to instrument our code. There is the one provided by the project, so Java. Then you have Node.js, the JavaScript client instrumentation, Go, Rust, Nginx, Kong, and more. The community has provided two other instrumentation, which is C# and C++. To instrument your code, there are few agents that will allow you to produce data without any changes on your code. In fact, it's only the case for Java, where you can load the instrumentation library with the Java options called Java agents. .NET is a .NET 4 package that you will need to add before building your application. On the other language, you will need to do small changes on your code. And if you're building Docker containers, well, at the end, we are in 2023. There's a big chance that you are already building your own containers out of your code. So then you will see that it's even easier when you're running in containers. For Node.js, you will need to import a library in your code and start the agents before your applications. In Go or Python, the SkyWalking community has provided a Docker image with their agents and the Go or Python runtime. So no changes required in your code. If you don't build containers, you can still install the instrumentation package for Go or Python, and it will be required when you're going to build your application. Similar to OpenTelemetry, SkyWalking provides common environment variable that would help us to configure the service name, the service instance, and also where do we want to send the backend, so the OAP server URL. To get details in your Kubernetes cluster with SkyWalking, you will need a couple of requirements. So to do so, you will of course rely on the C advisor included in kubeled, the kubestate metrics to get the status on the Kubernetes objects, the node explorers to get the health of the nodes. SkyWalking provides an event exporter that will collect the events and send it to the SkyWalking server. So it will mean that you will need to deploy each of those exporters, so kubestate metrics, node exporters, the event exporter, and so on, and then deploy an OpenTelemetry collector. The OpenTelemetry collector pipeline would be very simple. It will receive metrics using the Prometheus receiver. Then SkyWalking has already shared their scrap config required to collect the data from those various exporters. So here is the link to the scrap config provided by the community. But if you're looking to get details on the pod or even extend it with profiling data, this is where you need to deploy the SkyWalking eBPF probe named Rover. Rover would be deployed as a daemon set, as you can expect, and it will add also a cron job using the SkyWalking CLI to collect profiles in a regular basis. Last, the SkyWalking community has started to build a Kubernetes operator, helping us to simplify our journey to deploy and configure SkyWalking. So the operator will manage the deployment of our OAP server, the storage that we would like to use for our Apache SkyWalking server, the configuration. Also, we can also define how we want to inject the agents. In fact, it's only possible with Java. So this operator introduced several CRDs. So we have the OAP to deploy the SkyWalking server, the UI to helping us to deploy the UI of SkyWalking, the storage, determining which type of storage we want to use with SkyWalking. There's also satellite to manage the deployment of the satellites that we want to use with SkyWalking. There is fetch, helping us to configure OpenTelemetry collectors to collect metrics. To ingest the Java agents, the operator allows us to add the agents automatically based on label that you could be defining in the namespace or in our workload. Like explained in several episodes, the health of a service mesh, and in particular Istio, would need to report the health of the control plane and the health of the data plane. As you may know, Istio can produce from the control plane and from the data plane metrics, traces, and logs. So reporting the health of Istio in SkyWalking will obviously rely on those layers. So you will need to configure the Istio, in fact the mesh config, to enable metrics from the control plane in a Prometheus format, enable the service metrics from a data plane to send it directly to your OAP server, enable the traces produced by the Envoy. But you'll see that one big downside it requires to enable Istio to use Zipkin exporters. It will mean that the spans produced will not use the W3C trace context. So at the end, you will get some spans from the mesh, but if for any reason your application produces OpenTelemetry traces, then the trace won't consider even your application traces. So it's completely weird to see that they rely still on Zipkin. And again, as explained, you will need to add the collector to collect the things. The logs will send also directly to the OAP server. So there are a few requirements that sounds a bit strange, especially when you know what happens on the Observability community. So that's it for today's episode related to SkyWalking. So technically, SkyWalking provides lots of interesting features, but the big downside is the lack of compatibility with the common standards, which is OpenTelemetry. Just as an example, forcing our service mesh to produce Zipkin traces is completely not aligned with the new updates and work done by the Istio community that are now supporting OpenTelemetry. I'm very disappointed to not be able to use the open standards to report the health of the applications, to use collector to send the logs, the metrics. You're forced to basically use one part of the collector here. The other part will be sent directly to OAP, to the SkyWalking endpoints. Sounds strange. So if you have no intentions to use OpenTelemetry or even take advantage of the latest innovation work created by the community, then you can clearly explore SkyWalking utilizing their agents. Again, the value of SkyWalking is only limited if you are using their agents. If you are used to collect Prometheus data, OpenTelemetry traces, and view them in your observability system, then Apache SkyWalking won't be the right solution for you. The other aspect is the configuration. I mean, since I started this channel, I'm used of doing lots of configuration, exploring the docs, trying to implement solutions. But here in SkyWalking, the configuration is very complicated. The docs seems good, but they are pretty unclear, and so the journey will be very complicated. So if you need to use SkyWalking, then you will have enough time and courage to start and be successful with SkyWalking. The other big downside I would say is that from anything that you need to do, SkyWalking doesn't support, so you will need to add extra workload, extra exporters, extra collectors. So at the end, the overall resource usage required to observe a system will be quite heavy because you will need more components to achieve what you are looking for. So again, I think it's an interesting solution, sounds quite promising, but if you look at the various updates done by the observability market, I think the Apache SkyWalking should consider to change their approach and supporting more and more OpenTelemetry natively in their solutions. If you enjoyed today's content, don't forget to like and subscribe to the channel. So I will soon produce another episode, including the tutorial for Apache SkyWalking. You will see that for now, I won't have 100% coverage on the observability side with Apache SkyWalking. Maybe I did something wrong, but you will see. So be patient. This tutorial will come soon, probably in a week or so after this episode. So thank you for watching and see you soon for another episode.